Hello, everybody. Welcome back to another video. Wow, it's been a very long time since I have uploaded. My last upload was on October 3rd, and it's been way over a month since I have, and that's primarily because I went off to university, and life in university is very different to IB. It is much, I wouldn't necessarily say it's harder as of now, but I have a video upcoming about that and about the general transition from high school to university. But anyways, it's good to be back. Even though I haven't posted, I have been replying to questions. I think I've replied to a question every single day since October 3rd. I reply usually within an hour or two. So if you have any questions, always feel free to send it my way. This was a particular question I received from a student, and I think it's a really good question. And I think we should be able to tackle this kind of question if it does come up in an MCQ. As you can see, it's just 1 mark. And on the face value, it looks pretty difficult, right? How would you do this without a calculator? Some of you may be thinking. And that's the kind of question even I used to think when I used to come across such questions. But the thing is that when the IB, in a paper, when they give you such a question, they expect you to be able to do it without a calculator. And the only reason they expect that is because it can be done without a calculator. And since it's only 1 mark, it's not going to require much effort. That's already a hint. So I'm going to show you how to do this question without much effort. I'm going to show you a shortcut, what I use during exams. And in fact, I even use this in my university tests 1 or 2 times. So it just goes on to show how useful it is. So here the question says that the complete combustion of 15 centimeters cube of a gaseous hydrocarbon. What is hydrocarbon? As you can probably tell by the answer options, hydrocarbon is nothing but a compound which just has hydrogens and carbons in it. That's it. That's how simple. So don't get confused by fancy words. So when you burn or when you combust a gaseous hydrocarbon, it produces 60 centimeters cubed of carbon dioxide gas and 75 centimeters cube of water vapor. That is the standard combustion equation, right? If you combust X material, you get CO2 and water. I think that's pretty much standard. We've all learned about this in the chemistry course. Now they're asking us, what is the molecular formula of X? So we know that we have produced 60 centimeters cubed of CO2, and we know that we have produced 75 centimeters cube of water vapor. So this is all in gaseous. And we have started with 15 centimeters cube of X. And I've forgotten something over here, which is a very bad thing of me. Some of you may have caught it. I completely forgot to put the oxygen. Anyways, so yeah, we have 15 centimeters cube of this. They're not really told us the oxygen because it doesn't really matter. It's always going to be in excess, so it really doesn't matter. But they're asking us to now calculate the molecular formula of the compound that was burnt. Now, the standard thing you would do when you look at such a question is to, first calculate the moles of the gas produced and then the moles of the water produced, and then use the molar ratios to find out the ratio. And that's good. Okay, that's cool. But the thing is, you can't do that over here because the question doesn't allow you to use a calculator. So unless you can do 60 divided by the molar mass of CO2 mentally, unless you can do that, I think you're going to have a very hard time doing this question that way. So I'm going to show you a good way to do it. The first thing you want to do is look at the volume of the carbon dioxide, which is CO2. And if it's produced 60 centimeters cubed of carbon, that means that the ratio of the volume of the product, which is X. Now we know that X has C, X, and H, Y. X and Y is, I don't know how many carbons, I don't know how many hydrogens. But since it's producing carbon dioxide, and that is 60 centimeters cube of carbon dioxide, we can figure out the ratio of how much how much hydrocarbon produces how much carbon dioxide. Because all the carbon that is being produced in CO2 is coming from the hydrocarbon, if that makes sense, right? All the carbon dioxide is all the carbon dioxide that is being produced as a result of the hydrocarbon, because 1, the hydrocarbon is going to be the limiting reactant, and 2, the hydrocarbon is the only compound in the reactants which contains carbon, and you need carbon to make carbon dioxide. So I hope you can draw the link over there. So we can use this one ratio. So 15 centimeters cubed of the hydrocarbon produces 60 centimeters cubed of carbon dioxide. So that is a 1:4 ratio. So you can think for every one molecule of, for every 1 mole of hydrocarbon that you burn, you are creating 4 moles of carbon dioxide, if you take it that way. That's not accurate, but it's just a way of visualizing it, right? So you can technically put something, you can make it like C4. Okay. Next part. How do you calculate the hydrogen? Because we have got one part, which is X. Now we need to get the next part, which is hydrogen. They've told us that you have 75 centimeters cubed of water, and water contains H2, which is basically hydrogen, right? 2 hydrogens. And again, we know that all the hydrogens which are present in this water molecule are coming from the hydrocarbon, because no other reactant other than the hydrocarbon contains hydrogens, right? Only the hydrocarbon has hydrogens. So all the hydrogens that you see in this water are directly coming from the hydrocarbon. And we've been told that 75 centimeters cubed of water is being produced. Now, looking at this, you may think, okay, well, what I can do is the same thing I did earlier, right? 15 centimeters cubed of hydrocarbon produces 75 centimeters cubed of water. Well, that ratio is 1:3. That means H is 3. Well, no, that doesn't really make any sense, right? And why is that? That is because over here, we have 2 atoms of hydrogen. So technically, you are producing not 75, but 150 centimeters cubed of hydrogen, because it's 75 centimeters cubed of water. And each molecule of water has 2 hydrogens. So that's into 2. That will give you 150 centimeters cubed of hydrogen. I know this is all not chemically accurate, but it's just a way of visualizing, a way which you can process what I'm saying. So technically, you're producing 150 centimeters cubed of hydrogen. So the ratio is 15:150, not 15:75. So 15:150. Again, we can simplify this to 1:10, and that would mean that hydrogen is 10. And this is the molecular formula of our hydrocarbon. And that is an option over here, C. That is a correct answer. So hopefully you have seen how simple this is. This is really not about chemistry. It's more about logic and math. It's not about chemistry. That's how easily you can solve these questions. Hopefully you have understood what I have done over here. Just another revamp. I'm going to give you quick steps. When you see such a question, figure out the ratio of the volume of the carbon dioxide to the hydrocarbon, like we did. We got 1:4. One molecule of the hydrocarbon, just imagine one molecule produces 4 carbons, and then you can put this 4, you can use this ratio 4 as the number of carbons in your hydrocarbon, which is C4. And then the same thing with the hydrogens, 1:10. You can use this number 10 as the ratio of hydrogens to carbon, 10:4, 4:10, whatever you want. Hopefully that makes sense. That's it for this video. Thank you so much for watching. I have another video coming up soon, maybe tomorrow, where I explain about my university life and how I felt it is. And I know that a lot of the November students have completed their exams. And congratulations to you for that. And I know that you will also be heading off to university soon, so you may find that video helpful. Maybe many of you coming to where I study, which is the University of Edinburgh. So maybe I see you there. Who knows? Anyways, thanks for watching. Take care of yourselves and goodbye.